Mashallah, at DevNext Belgium 2024. It's been a long 3 days, and this is our last interview of the conference. And last but not least, I have Gunnar here with me. Welcome.
Hello.
And so, here's the thing. I'm the only person in the Java world who didn't hear about 1 billion row challenge.
Maybe one or two people have not heard about it.
So for us, for the 1 or 2 people in the Java world, tell us what it is.
Right. So it's pretty much all in the name already. It was a coding challenge which I ran for and with the Java community earlier this year. And the idea was to, have a file which has essentially temperature measurements and process that file as quickly as possible to determine what's the minimum value per weather station, the maximum value, and the average value. So you had pairs of values, let's say Antwerp 12 degrees, Hamburg 5 degrees. So you had to process those values, and the caveat was, it was 1 billion rows. So the file was about 13 gigabytes of size. And of course the task was to do this as quickly as possible, and it attracted people, so they spent quite a bit of time on doing that.
It sounds like an interesting challenge, because you obviously cannot load everything to heap, and it's too large, and all this stuff.
You could actually.
You have a heap of large enough.
So, people first of all wouldn't use the heap because they would use like memory map files and
exactly
everything like off heap, right?
Off heap, exactly. Let me guess, the winner used C code and then stacked it from GNI.
So you could not do that actually. It's an interesting idea. You could not do that because the way I set it up, it was meant for the Java community, and you had to write Java code. And now,
that was like you couldn't pretend that it's Java, but actually write C.
And for GNI, you need to have a little bit of wrapper code, right? So you could not do that. But people, for instance, use GraalVM, like the native image capability, so they could have like a small native binary, very fast to start up.
You know what? I'm excited to hear the insights. All right. So what did we learn?
What did we learn? Well, first of all, I would say, Java gets there, right? And I mean, maybe I'm spoiling the surprise, but on the machine which I ran this on with 8 cores, people would get down to 1.5 seconds to process this entire file. So it's really fast, right?
It is impressive.
And actually, it was a very beefy server, so I had 32 cores. So with all the 32 cores, hyper-threading, 64 threads, it would go down to 300 milliseconds. So like really amazing.
All right.
And what did people did? Well, they used, as I mentioned, GraalVM, native binary, just to have it start up very fast. They parallelized, so they made use of all the cores. Of course, they used what's called SIMD, single instruction multiple data. So that's instruction set extensions of your CPU, which essentially apply the same operation to multiple values at once. They did all kinds of bit level tricks and measure, to
optimize, to squeeze
as much as possible.
Another millisecond.
They disabled garbage collection because they figured out, for that problem we don't need garbage collection, so we just we can save the CPU cycles on that. They implemented their own custom hash maps for the aggregation step of that. All kinds of interesting stuff.
Nice. GPU?
Well, people asked about it. So the thing is, I had to run this on one machine, right, to make this comparable. So I took all the submissions people did, and this box didn't have any GPU. But I don't know, maybe this could be something for next year, GPU problem. But in this case, it was like really just on this AMD EPYC CPU and taking the advantage as much as possible from that specific CPU.
Nice. So obviously, it was a very synthetic problem, right? And the solutions were very tailor-made for this particular problem. So, but I wanted to ask you, what can we learn and borrow from this very specific problem to our general software engineer?
Yes, absolutely. I mean, so yes, you're totally right. So the implementations, they were tailor-made specific for that problem, and people used hash functions which wouldn't collide for the particular data set, all that. Still, many of the techniques people would, for instance, employ when they build like a database kernel, like doing all the SIMD stuff and so on. I mean, it will be a bit slower because it's not optimized for a particular data set, but still they would do the same kinds of things. But for me, one interesting takeaway was So I started with like a baseline implementation, canonical Java code using the Streams API, what you would do, right? A code I would write. And this would run in a bit like 5 minutes, 4 minutes, 50 seconds, something like that.
That's like your naive implementation.
Yes,
out
exactly.
Of the box. This is what
That's what you would do, right? Yeah. And now the interesting thing is, so getting faster by 1 order of magnitude, going down to 20 seconds. You still can write Java code which reads well, which is maintainable, which I would be able to write, and it's canonical code, I would say. And you can get there, down to 20 seconds, no problem. But then going down yet another order of magnitude, going down to 1.5 seconds. This is where you do all the crazy stuff.
All the crazy stuff.
And the question is, should you do this or should you not do this, right? It depends. Like in your regular job, probably wouldn't do it. But if you work on a database or if you want to do well in that sort of challenge, well, then you would do it.
It reminds me, Alexei Shipilov.
Right, he took part in it. He was part of it.
Of Sun Fame and then Oracle and now in Amazon.
Right.
He had one of his concepts was a curve, performance curve.
Right.
That of
totally.
3 colors.
Exactly.
The green, which is like, okay, this is what you really definitely should do, and because why not?
Exactly.
And then the yellow. The yellow is taking it from 5 minutes to 20 seconds.
Right.
It's kind of performance optimizations heavy, but still makes total sense. Normal code, nothing too crazy.
Don't do the stupid things.
And then the red, the massive code that doesn't make any sense in any other context of this particular scenario that you really need to be careful getting into.
Yes, exactly.
So it's exactly the same thing.
Yes, pretty much that, yes.
So the biggest saver, the biggest differentiator.
Right.
One thing that you do and you get from 5 minutes to something.
Right.
Like, I don't know.
Definitely parallelize the code, right? And this again comes back to doing the simple thing. So if you use the Java Streams API, just adding like .parallel brackets, that gets you down to, I don't know, what, like 70 seconds or whatever. So just, parallelizing that pipeline, it makes all the difference. So that people did, then like doing all like, this SIMD stuff, or there's a variation of that called SMAR, which is SIMD within a register. So, trying to load multiple bytes as a single long and then apply some bit level magic to that. People did that. One interesting thing I also noticed is if you look at the fastest implementation, they actually have the same processing loop like 3 times in a row. And now you would wonder, why do they have like the same loop 3 times? It doesn't make sense, right? It's like, this is like written down sequentially. It should be executed sequentially.
It should be slower than faster.
Yeah, it doesn't make much sense. But as it turns out, well, the CPUs, they have multiple execution units, and now the compiler will figure, okay, those loops, they don't have any data dependency. So actually, we can parallelize this. So this code, it's written sequentially, but it's executed concurrently. And now, of course, it's super fascinating. I had no idea this would be a thing. And then, of course, the thing is, you have this maintenance questions, right? Because like you have the new guy joining the team, they see, oh, this is this code, let me go and refactor it and clean up a little bit, right? And then, of course, like boom, all the optimizations are out of the window.
Fascinating. And, this is the magic that Java does behind the scene for us, and probably at least we should document on.
Absolutely, yeah, you should put a comment there. Don't clean it up, please.
Yeah, because you have no idea what they're doing. And if you want to learn, ask Alexei Shipilov, and good luck. Getting back to the main. The main needle mover,
right?
The parallelization,
right?
It sounded very familiar to me because Build Version Lab and Gradle.
Oh yeah.
Right. There is we experience exactly the same effect.
Did I set you up for this?
It was perfect. I didn't pay Gunnar. Exactly the same effect.
Right.
On this machine right here, I have a build that runs for 2 minutes, 120 seconds.
On one core, or?
I add one line of running it parallel on all the cores, and the build time goes from 2 minutes to 10 seconds.
Right, yes.
That's 12 times performance gain.
Just using all your cores.
With one line of code.
Yeah, totally.
So I'm not surprised that this was the biggest needle mover.
Yes.
And obviously, but I think the fascinating is the red. Is the red area
yes, of course.
It's like the things that blow your mind.
Exactly. That's also why my talk was actually called like 1BRC, the 1 Billion Row Challenge, nerd sniping the Java community, because that's what it is, right? So like all the people, and as I mentioned, like Alexei, but also Cliff Click, one of the OGs from Java, right?
Yeah.
Thomas Würtinger from the GraalVM team, and many other people you would know. They all, got nerd sniped, and they took part of that because it's just, I want to do that, and I want to see how fast I can be, right? It's just like this natural inclination. Actually, Thomas Würtinger, so he teamed up. There were other people, and this was also one of the ideas I had for this. So this was for people to learn and to inspire each others to learn. So you could always take a look at the implementations from others. So it was not a secret. And of course, you shouldn't just like take somebody else's code, like submit it as your own. That wouldn't make sense, right? But you were free to take inspiration, apply their tricks, and that's what people did. And in this case, in the case of the winning team, they actually teamed up and put in a joint submission. And the cool thing was one of the guys who actually he got hired now also into the compiler team working on GraalVM. So he did such a good job and he came up with cool things, and now he works on the GraalVM compiler.
What
How
a
cool
lovely
is that?
story.
Yes, it's amazing, isn't it?
Gunnar, that was a real pleasure. I'm glad I didn't hear about it
Awesome,
before
yes,
today, because
that's great.
I wasn't like to hear it from the organizer and with all the cool stories. Thank you very much
My
for
pleasure.
coming.
Thank you so much for having me.
And you folks, thank you very much for being with us with Build Proportion Lab for the last 3 days here at DevX Belgium 2024. Stay tuned for more episodes of the Build Proportion Lab somewhere in the future. As you might hear through the episodes, we try to even organize some of the shows right here live. We'll see what pans out. And with that, thank you very much, and bye-bye for the last time.
Bye-bye.